Hey Ava. Hey Geometries. This is Mr. Bloom. I been asked to look at these two problems, actually three problems. So we're going to start out with problem question number 2 right here. Find the area of a regular polygon below. Round your answer to the nearest tenth. It's a hexagon. So I want to make sure you see what's going on with this hexagon. Okay, so we've got a shape. It's a hexagon. And we're going to get it a little thinner there. Okay, so I've got a hexagon. And what I'm going to do is draw it in here. Okay, and let's start marking up our hexagon. Now, when we're working with this hexagon, we know some stuff. We know the side lengths are 4. We don't, and we're supposed to look for area. Okay, so find the area of the regular polygon below. Round your answer to the nearest. Okay, that's what I'm looking for. Here's the deal. There is something called an apothem. Well, you know, I'm going to do this a couple different ways. This is from the 10-5 quiz. So I'm going to find the measurements in this one triangle. Remember, that's half of that whole triangle. Okay. Now the things I've got to do, I've got to go 360 divided by 6 is 60 degrees. That is the big angle, but I got to cut that 60 in half to get 30 degrees. And that's what this is. Okay, now remember this is a 30, 60, 90 triangle. So this is 2 and this is 2. That makes that whole side 4. 2 times 2 is 4. And 2 the square root of 3 is my apothem. So now I can find the area of this hexagon by talking about, by talking about my area being 1/2 a n s. 1/2 of a being 2 the square root of 3, n being the number of sides, 6, and s being the side length, 4. Okay, now I've got 24 the square root of 3, if I multiply that together, all right, or if I take my calculator and pop that in there, it's 24 the square root of 3, which is 41.569. That is 41.569. Here they say round to the nearest tenth. That's the 10th place. So this answer needs to be 41.6, and it is meters squared. Okay, 41.6 is where we should go. Be careful not to round until the very end, because our rounding is a big deal. And how I round it is I'm supposed to go to the 10th. And at the 100th position, it's bigger than 5. So that's why the 10th position goes up to 6. All right, so that's that first one. Now let's look at the second one here on this page. We're supposed to find the area of a regular pentagon, regular polygon, round your answers to the nearest tenth. Now when we're doing this, we're supposed to work with a 15 gon. So I've got a 15-sided figure. So I'm going to get rid of my hexagon here, put it over here, and we're going to work with a 15 gon. A 15 gon is a 15-sided figure. Okay, 15-sided. Okay, so I've got to go 360 divided by 15. Well, when I take 360 and divide it by 15, I should be getting, I think, 24. Okay, so that's 24 degrees from my central angle. So my isosceles triangle, I know it's is probably bigger, but coming out of my 15 gon here is got a 12 and a 12 because that's 24 degrees total. Now they also tell me that the perimeter is 120, so 120 divided by 15. Okay, I go 120 divided by 15. It's looking like it's 8. So I know that this side is 4 and this side is 4 on my side measure. So the things I already know about this 15 gon. A, I have to find n, the number of sides, is 15. My side length is 8. Now remember, that's perimeter, and I already know that's 120. They tell me that right there. So now I've got to find the apothem, and I'm going to use tangent for that. And this is a right triangle. Okay, I'm going to get a different color here. So I'm finding the apothem, and that is, keep in mind, I'm going to work with tangent. Sorry, I wrote the apothem and I wanted to write tangent. So I've got the tangent of 12 degrees is equal to 4 over opposite over adjacent, which is the apothem. So I've got the apothem is equal to 4 over tangent of 12. So now I've got my equation, remember, 1/2 my area is 1/2 a n s, 1/2 my apothem, which is 4 tangent of 12. Number of sides is 15, the side length is 8, and 15 times 8 is 120. So I've got 60 times 4, which is 240, divided by the tangent of 12, and I put that in my calculator. And you didn't have to put that together, I just making things a little easier when I grab my calculator. Divided by tangent of 12. Now my answer is 1,129.111. 1,129.111226. And I'm supposed to round to the nearest tenth. Well, that's my tenth, and because that's less than 5, nothing happens. So my answer is 1,129.1 meters, or feet, excuse me. Okay? So that's my answer for the second one. Now, a lot of times when you're doing this, you'll notice that there's an issue with just rounding. And most of that rounding issue happens because you used a rounded number as you went. I'm trying to avoid the rounding error as I do my problems. Let's go to our last problem here for our frequently asked questions. Okay, this is an octagon. Okay, so I've got an octagon here. It's a regular polygon, and I'm rounding to the nearest tenth. So remember, 360 divided by 8 is going to give me a 45. Okay, half of 45 is 22.5 degrees. And what is that? Remember, coming out, this is 22.5 right in there. Half of 8's 4. Remember, I've got this central angle of a triangle coming out of here, and I just blew it up right there. Okay, now, that's a right angle. I've got to find my apothem. So this is my tangent of 22.5 is equal to 4 over the apothem. So my apothem is equal to 4 divided by the tangent to 22.5. Now, I'm going to leave it like that so I don't have rounding error. My area of my value of my polygon, 1/2 a n s. 1/2, where a is 4 tangent 22.5. A and n, that's a, and n and s. So n is the number of sides, 8. S is the number, length of the sides is 8, which is 64, 8 times 8. So now I got 128 on top, if I multiply that together in my head, divided by a tangent of 22.5. So I have 128 divided by a tangent of 22.5, and I get 309.01. Okay, so my answer becomes, 309, sorry, if my pen's changing as I lean my fingers down, 309.01. So rounded to the nearest tenth, that's 309.0 meters squared. And we leave that 0 because we're showing the person grading that we considered that value. Okay, I hope these things help you out. If you have any other further questions, please send them to me. Have yourselves a great night.